Okay, so in this unit, we're going to talk about the mole. All right, and we're going to be doing some calculations with the mole. So we have to understand what the mole is. Okay, so what is a mole? Basically, it's just a number. Okay, it's a number similar to the word dozen. Okay, like we have a dozen eggs, so we have 12 eggs. We have a dozen, pencils, so we have 12 pencils. So the mole equals a number. All right, and the one mole, the number that it's equal to, equals 6.02 times 10 to the 23rd of whatever it is. A mole of pennies, a mole of marshmallows, a mole of grains of salt. It doesn't make any difference. One mole equals 6.02 times 10 to the 23rd, whatever it is. Okay? We can equate the mole to several things. We can equate it to particles. All right, we can equate it to grams, and we can equate it to liters. All right, these are all conversion factors that we have using the mole. Okay, so we're going to talk about each one of these separately, so you get a good idea of how to calculate things using the mole. Okay, so the first one we're going to talk about is moles to grams. Okay, and grams to moles and all that good stuff going forward and going backwards. The first thing you have to be able to understand with the moles to grams is that you're going to be using your periodic table a lot. All right, so 1 mole of any element equal to the atomic mass of the element. Okay, so that's where your periodic table comes in. All right, so 1 mole of aluminum equals, you look at your periodic table, 26.98 grams of aluminum. Okay, so all you have to do is look at your periodic table. 1 mole of hydrogen equals 1.01 grams of hydrogen. Obviously, the further down you go, the heavier the elements become, the more mass is equal to 1 mole. So basically, 1 mole of aluminum atoms is equal to 26.98 grams of aluminum. Okay, and so on. It's not that difficult. So if we did 1 mole of nickel atoms, okay, 6.02 times 10 to the 23rd nickel atoms is going to give us 58, can't read it, 8.69 grams of nickel. Okay, and we're gonna round, we're gonna round to 2 decimal places. Okay, when talking about this, so a lot of periodic tables will give it to the 3rd decimal place or even to the 4th decimal place, but we're going to just stop at 2. All right, so that's the first thing you have to know. The second thing you have to know is how to calculate for an entire formula. So 1 mole of, let's say, CO2, all right, how many grams is that? So we're going to say carbon, we have 1, and each one gives us 12.01 grams. All right, and oxygen, there are 2 of them, and each one gives us, each one gives us 16.00 grams. All right, so 2 times 16 gives us 32.00. So when you add these together, you get 44.01 grams of CO2 is equal to 1 mole of CO2. So all you're going to do is take the elements that they have, the number of atoms of each one, and add those together. Okay, so let's do another one. So 1 mole of Al2O3. Okay. And the abbreviation, abbreviation for mole is MOL. Okay. MOL is equal to 1 MOLE. I don't know why the abbreviation is just one letter less. It just is. All right, so let's look at the mass of 1 mole of aluminum oxide. Okay, so aluminum, we've got 2 of them, and each one is going to give us 26.98 grams. Okay, then we have oxygen, there's 3 of them, and each one is going to give us 16.00 grams. Okay, so when we multiply those together, we have 53.96 and 48.00. So when we add those together, we have 101.96. Okay, so there is 101.96 grams of aluminum oxide is equivalent to 1 mole of aluminum oxide. Okay, so that's how we find the mass of 1 mole. All right, but your questions are going to ask you how many grams are in half a mole, or how many grams are in 5 moles. All right, so we need to look at calculating those. Okay, so when we go from moles to grams, we're going to look at our periodic table again. So let's go over a couple of questions. And now let's go forward first. Okay, so how many grams, or what is the mass of 3.62 moles of carbon have? Okay, so there's our question. How many grams does 3.62 moles of carbon have? All right, now, if you remember way back when we talked about conversion factors, we showed you a way to do this. All right, and it's called dimensional analysis. So you're going to take what you start with. Okay, so you have 3.62 moles of carbon. Okay, and the moles of carbon, okay, your moles of carbon is essentially your unit. Okay. All right, so we're going to find moles of carbon. 1 mole of carbon is going to be equivalent to grams of carbon. Okay, that's what we were doing in the previous steps. We were basically figuring out this conversion factor. Okay, so this thing right here, this number, whatever we find, that's your conversion factor. And don't let it get you, don't let it trip you up. It's a conversion factor is nothing, that you haven't dealt with before. Like I said, we talk about the word dozen. A dozen just means 12. Okay, so you have 12 eggs in 1 dozen. So we're going to look at how many grams we have in 1 mole. And we look at our periodic table. So we have 12.01 grams in 1 mole. That is our conversion factor. Okay, now we treat this like a math equation, and we divide everything that can be divided. So moles of carbon and moles of carbon can be divided out, and we are left with grams of carbon, which is what we want. Okay, so we're going to multiply across the top. Okay, we're going to multiply up, and then divide by the bottom. Okay, so we have 3.62 times 12.01 divided by 1, essentially. Okay, and when we do that, we get 43.48 grams of carbon. And there's your answer. That's how many grams of carbon are in 3.62 moles of carbon. All right, let's do another one. Let's let's go backwards. Okay, let's start with let's start with grams. So how many moles are in 67.3 grams of aluminum? Okay, there's our question. Again, we're going to start with what we have. We have 63 grams of, or sorry, 67.3 grams of aluminum. All right, so we have grams of aluminum. We need to get to moles of aluminum. All right, remember the first thing you should do, the very first thing you should do is put this unit, whatever this unit is, directly on the bottom. So grams of aluminum, okay? And that is going to give us 1 mole of aluminum, okay? So again, this is our conversion factor that we're looking for. All right, so grams of aluminum, we look at our periodic table, and we have 26.98 grams of aluminum equals 1 mole of aluminum. All right, now, in the last case, we multiplied across the top and we divided by the bottom. Nothing has changed. Okay, now it's just 67.3 times 1 divided by 26.98. All right, and when you do that, you get 2.49 moles of aluminum. Okay, so how do we get moles of aluminum? Well, grams of aluminum canceled out, and we're left with moles of aluminum, which is what we're looking for. Okay, so 2.49 moles of aluminum is your answer. Let's do one more in this direction, and that should be good. Let's see. How many moles? All right, so there's our question. How many moles would be in 384.2 grams of CO2? So 384 grams of CO2 is what we have, so that's what we're going to start with. And immediately put grams of CO2 at the bottom. Okay, and then we're going to equate that to 1 mole of CO2. Okay, so we have to figure that out. So carbon, there's 1 of them, all right, and each one is 12.01. And oxygen, there's 2 of them, and each one, if you look on the periodic table, is 16.00 grams. All right, so that's 12.01 plus 32. It's going to give us 44.01 grams. So 44.01 grams of CO2 is equal to 1 mole of CO2. Again, this is just a conversion factor that we find. And the reason everyone is different is because every atom is different. Their mass is different. Every molecule has a different mass. So we have to calculate that conversion factor every time. When we get into particles and we get into liters, the conversion factor is more stable. Okay, but for this one, you have to calculate it every single time. All right, so grams of CO2 divides out, and you're left with moles of CO2. Nothing has changed mathematically. It's 384.2 times 1, okay, multiply across the top and divide by the bottom, 44.01. When you do that, you end up with 8.73, not 87, 8.73 moles of CO2. Okay, and there's your answer. So what have we done? The first thing we looked at doing was figuring out, you know, our molar mass. Okay, is what this is called. This is called molar mass. And really all it is the mass of 1 mole. Okay, so molar mass is the mass of 1 mole. So these, all of these right here, all conversion factors. They all equal 1 mole, So they are all the conversion factors that we're looking for. The same thing with this right here. Okay, that's the conversion factor we just used down at the bottom. All right, so when you're looking at the molar mass and you're calculating the molar mass, or sometimes called the gram formula mass, all you're doing is finding what that conversion factor is. All right, so then down here, when we're actually calculating things, we can use that. Okay, that is grams to moles, moles to grams.